Assalamualaikum and good day everyone. We are a Bachelor's of Degree student in Mathematics Management, currently in semester 5. This presentation is prepared for the subject ISP610 Business Data Analytics. The title of our group project is Sentiment Comparison between Lazada and Shopee Online Shopping Experience. This project actually focus on applying business data analytics and machine learning technique, particularly sentiment analysis, to analyze customer review and compare online shopping experience between Lazada and Shopee. First, I will explain the project background. The rapid growth of e-commerce has significantly transformed consumer purchasing behavior. Today, customers rely heavily on online review before making purchasing decisions, as this review reflect real user experience. Platforms such as Lazada and Shopee have become dominant online marketplace in Malaysia and Southeast Asia. Customers frequently share feedback related to product quality, delivery performance, pricing, and customer service after completing their purchases. This review contains valuable information that reflect customer satisfaction and dissatisfaction. However, the main challenge is that customer reviews are written on unstructured textual format and exist in large volume, making manual analysis inefficient and impractical. Therefore, sentiment analysis is introduced as an analytical solution. Sentiment analysis enables the automatic classification of customer opinion into positive and negative sentiment, allowing meaningful insight to be extracted systematically. So, in this study, sentiment analysis is used to compare customer perception between Lazada and Shopee, providing a data-driven understanding of customer satisfaction across both platforms.
For this project, we focus on customer experience in online shopping platforms, especially Lazada and Shopee. These platforms receive a large number of customer reviews that reflects users' satisfaction and dissatisfaction. However, analyzing this review manually is really time-consuming and very subjective. In addition, there is limited research that directly compares customer sentiment between Lazada and Shopee using analytical tool. Therefore, this study aims to compare customer sentiments toward Lazada and Shopee online shopping experience using sentiment analysis supported by RapidMiner and Tableau.
For objective, there are two types of data, descriptive analytic and predictive analytic. For the descriptive analytic, to analyze and compare customer sentiment toward Lazada and Shopee based on online customer review. Next, to identify and distribute the positive and negative sentiment. And the last one, to visualize sentiment pattern and trends between Lazada and Shopee using descriptive analytic technique. For the predict analytic, to develop sentiment classification model to predict customer sentiment based on online shopping review. Next, to compare and perform for at least 3 machine learning classification algorithm and identify the best performing model. And the last one, to predict sentiment for new unseen customer review using the selected best performing model. Next, for methodology, this study used quantitative data analysis approach based on secondary data from online customer review. The data is collected from Lazada and Shopee using web scraping. At first, the data is raw and unstructured text. Next, data cleaning and preparation are done to remove unnecessary word, error, and irrelevant information. The text is then processed so it can be changed into structured format that is suitable for analysis. After that, descriptive analysis is used to summarize customer sentiment patterns. Then predictive modeling is applied to classify review into positive or negative sentiment using machine learning. All these steps are carried out using RapidMiner to ensure the process is organized, systematic, and easy to reproduce.
In terms of methodology, this study focuses on text-based customer review collected from online resources related to Lazada and Shopee. RapidMiner is used to perform text pre-processing and sentiment analysis, where reviews are classified into positive and negative sentiment. These results from RapidMiner are then imported to Tableau to visualize and compare customer sentiment between two platforms. This allows clearer interpretation of pattern and difference in customer experience.
At this stage, the collected datasets are examined to understand their structure, attribute, and overall characteristic. The primary attribute in both datasets in the review text, which contain unstructured textual data. Additional attributes, such as platform type, which is Lazada and Shopee, are used to differentiate review between the two platforms. An initial inspection is conducted to identify missing value, duplicate entries, and inconsistent within the dataset. Understanding the nature of the data is essential to ensure appropriate pre-processing techniques are applied before performing descriptive and predictive analytics. So, this is the data description of Lazada and Shopee. There's also have the raw data of Lazada and Shopee. This data analysis was submitted to discuss and compare user sentiment of Lazada and Shopee online shopping sites. To begin with, customer review and feedback on the App Store and online platform were analyzed sentimentally to know how people felt and their general attitude towards the two apps. Secondly, the user rating, number of review, and happiness votes are examples of quantitative indicators that were analyzed to determine the level of satisfaction and engagement on the two websites. This measure allows conducting a comparative analysis of the user perception of Lazada and Shopee. Third is review submission were also analyzed over time to understand how users change their sentiment over time, especially during a promotion or significant update of the application. Lastly is similarities and subjects that were mentioned frequently in user review, including the service, pricing, user interface, and customer support were also found to outline the strengths and weaknesses of each platform. It is a complete scope to a significant comparison of the online shopping between Lazada and Shopee.
Next, data preparation. Data preparation is the process of organizing the data so it can be analyzed properly. In this step, only the important attributes are selected and unnecessary columns are removed. The data format is also checked to make sure everything is consistent and correct. All review text is prepared so it can be used for text mining and sentiment analysis. Proper data preparation help reduce error, make the analysis faster, and improve the accuracy of the result.
Figure is represented for Instant Data Scraper, a browser-based web scraping tool designed to automatically extract structured data from web page without requiring programming knowledge. It operates as a browser extension commonly used with Google Chrome that detect and collect repetitive data patterns such as table, list, and review section from website. In this project, Instant Data Scraper is used to collect customer review, rating, and feedback from Lazada and Shopee platform. The tool enables systematic data extraction from App Store or website review page, ensuring consistent and reliable dataset for sentiment analysis and comparative evaluation. Data aggregation. One of the most important things that was done in the process of combining the data from Lazada and Shopee was to merge all the attribute name into one single entity that was called review. This was intended to support uniformity and enable more efficient analysis throughout the various platforms. The data aggregation produced aim to reduce potential conflict resulting from different attribute names by standardizing the terminology. In addition to streamlining the dataset, combining various quality under the general word review made the analytical process more efficient and rigid. This careful preparation guaranteed that further analysis can navigate the merged information with ease and support a more unified comprehension of pattern and trend within the diverse platform. Next is data transformation. The first one is nominal to text. The operator illustrated in figure converted to selected nominal attribute type to text, also transforming all these attribute value into string value. The choice of the nominal to text operator was driven by the necessity to convert the nominal type of raw dataset into a text type. Second is abbreviation. The abbreviation used to condense a short form into its full form refer to the practice of employing a shortened representation of a word, phrase, or term to streamline communication and conserve space or time, with the subsequent need to expand or elaborate upon it to convey the complete and detailed meaning of the original expression. For example, before delivery was fast, TBH Shopee was better. After delivery was fast, to be honest, Shopee was better. The third is filter example. The filter example function was utilized to determine the data to retain and exclude from the raw dataset. In this step, neutral data from the sentiment attribute was specifically chosen for removal. This decision stemmed from the objective of instant expressing either positive or negative sentiment. The deliberate exclusion of neutral sentiment aimed to underscore more polarized opinion, facilitating a more focused and insightful examination of sentiment within the dataset. The last one is translate. The review on Shopee Malaysia writing in Bahasa Melayu was translated into English with the help of Google Translate. For example, before, harga murah tapi servis pelanggan lambat. After, cheap price but customer service is low.
Next, we move to the data cleansing. Before performing any descriptive or predictive analysis, it is crucial to ensure that the dataset is clean, consistent, and suitable for modeling. This stage is known as data cleansing. First, duplicate customer review were removed using the remove duplicates operator in RapidMiner. This step actually prevents repeated data from biases the analysis and affecting model performance. Next, the nominal to text operator was applied to convert nominal attribute into the text format, ensuring that the review data could be processed in the text mining operations. Then, the set role operator was then used to assign the sentiment attribute as the label, which is required for supervised machine learning classification. After that, the filter example operator was applied to remove neutral review, allowing the analysis to focus only on the positive and negative sentiment. This helped improve classification clarity and model effectiveness. In addition, emoji, symbols, and special characters were manually removed using the Microsoft Excel. Although emoji may express emotion, they introduce noise and may cause encoding issues during text processing. Overall, the data cleansing process improves data quality, reduce noise, and ensure that the dataset will well prepared for predictive modeling.
Now is data tagging. The first figure is represent raw dataset of Lazada and Shopee. Second figure is represent clean dataset of Lazada and Shopee after pre-processing. Okay, next. The first figure shows the total data of 1050 collected. Second figure is show new dataset with total data of 150 collected.
So, this is the data polarity. Abstract sentiment is used to create a sentiment score on an existing text attribute. Once the sentiment has been extracted, generate attribute is used to generate a new attribute named sentiment by using mathematical expression. Review with a score greater than 0 were categorized as positive, while those with a score less than 0 were labeled as a negative. If the score equals 0, the review were designed as a neutral. The dashboard display was designed to assist users in addressing issues related to the sentiment analysis of Lazada and Shopee.
After completing data cleansing and preparation, the next phase is in this presentation is predictive modeling. Predictive modeling aims to predict the sentiment polarity of customer review, either positive or negative, using machine learning algorithm. In this study, K-fold cross-validation was used to evaluate the predictive model. Instead of dividing the dataset into a single fixed training and testing speed, cross-validation allow a more robust and unbiased evaluation. The dataset is divided into k equal fold. In each iteration, one fold is used as the testing data, while the remaining fold are used for training. This process is repeated k times and the model performance is averaged across all iterations. This approach ensures that every data point is used for both training and testing, improving reliability and reducing evaluation bias. The primary evaluation metric used in this study is accuracy, which measures how well the model correctly predicts customer sentiment.
In K-fold cross-validation, the dataset is divided into K equals subset 4. This process is repeated K times and the final model performance is obtained by averaging the result from all iterations. During each iteration, one fold is used as testing data while the remaining four are used for training. This method ensures that every data point is used for both training and testing.
Before applying the machine learning model, text processing was performed using the process document from data operator in RapidMiner. This process includes first tokenization, which breaks the review text into individual words. Second, stemming using the Porter stemmer to reduce words to their root form. Third, stop words removal, such as and, the, and with. Last is case transformation, which is converting all text to the lowercase. This step converts unstructured text into a structured numerical representation, allowing machine learning algorithm to process the data effectively.
In this study, decision tree was applied to the cleanest data of 1050 customers reviewed from Lazada and Shopee. The model was evaluated using K-fold cross-validation to ensure unbiased and unbiased performance. Decision tree was compared with other models, namely knife Bayes and K-nearest neighbor, or KNN, to assess accuracy, precision, and recall.
The first predictive model used in this study is naive Bayes. Naive Bayes is probability-based classification algorithm that applies Bayes' theorem to calculate the likelihood of a review belonging to a particular sentiment class. In a sentiment analysis, the model predicts sentiment by analyzing the probability of words appearing in positive or negative review. The term naive refer to the assumption that each word is independent of the others. Despite this simplifying assumption, name bias is widely used in text mining due to its simplicity, efficiency, and strong performance when handling high-dimensional text data. Using key-fold cross-validation, the naive Bayes model was evaluated across multiple subsets of the dataset to ensure consistent and reliable performance results. The second predictive model applied in this study is K-nearest neighbor, also known as KNN. KNN is a distance-based classification algorithm that predicts the sentiment of a review by identifying the key most similar review in the dataset. The sentiment is determined using majority voting among the nearest neighbor. Unlike other models, KNN does not build an explicit training model, but instead relies on similarity comparison during prediction. Based on the result obtained from k-fold cross-validation, the k-nearest neighbor model achieved the highest average accuracy among the model tested. Therefore, KNN was selected as the best performing model for sentiment prediction of this study.
Now, based on the model performance from KNN, naive Bayes, and decision tree, we can see that we are using the accuracy as the model performance main metrics. This model relies on the similarity between the data point rather than explicit training. And among the model that has been tested, KNN demonstrates a superior performance, having around 78.65% than naive Bayes and decision tree. So we can see that having the most accuracy is the KNN rather than naive and decision tree.
New dataset. Our best performing model is the K-nearest neighbor or KNN model with an accuracy of 78.65%. Based on this result, we use the KNN model to test a new dataset with 149 reviews. After testing, the model achieved a higher accuracy of 85.91%. This shows the KNN model performed well and effective in classifying customer sentiment.
In conclusion, this project demonstrates how sentiment analysis can be used to compare online shopping experience between Lazada and Shopee. By combining RapidMiner for text analysis and Tableau for visualization, large volume of customers' review can be transformed into a meaningful insight. The finding provide a clearer understanding of customer perceptions and can support better decision making for e-commerce platform.